right, and now let's jump back where we were and start looking at object-based programming. So we just saw procedural programming, how we can just go through a main class, do the various items, result. Oops, not clicking on the right screen there. There we go. Object-oriented programming. All right. For this example, we're going to look at having a fraction. We've seen examples of classes before and fractions. So let's start looking at how we can implement a fraction API, really, object. What we have is, because what we have our class fraction. We're going to be able to create a new instance of the fraction. We're going to have then various other methods. So get numerator, get denominator, add fractions, dispose, split, etc. So we have this idea about the fraction. Let's just go ahead and look at how we might use that in code. So we have our main code, and we want to compute the sum of 2/3 and 1/5. We have our class main, we have our function main at the entry point. We're going to create 3 fractions, a, b, and c. We're going to let fraction a be a new fraction. We're going to go ahead and initialize that with the values 2 for the numerator, 3 for the denominator. Likewise, we're creating a fraction for b. We're going to then assign to c, a fraction variable we created, a plus b. We're going to kind of doing this in an object-oriented way. Then we print the result, the value of c, and then that's our program. So when we run this, we should see 13 over 15 being printed to the. This is an example of the abstraction implemented. The abstraction is that we just have this thing called a fraction. We can then assign it values, numerator, denominator. We can then have it add and then print the results. In terms of what the main class is seeing, we don't care anything about how it's being implemented. That's its own separate beast. We simply are using fraction class. On the other hand, to implement this, then we need to go into the details and write the code. Let's go up and build the fraction class. We're going to create a fraction.jack file. Of course, create the first line is going to be the class fraction, and then we're going to start working with it. Each fraction, each instance of the fraction needs to have access to a numerator and a denominator. So we're going to declare those as field variables, and that's kind of like a property you can almost think of. We're also going to have a few helper functions, accessors. Because we cannot ever access the fields directly, we need to then create functions that can access that, like a private variable. We have get numerator, get denominator, and those are just simply going to then return the fields of that particular variable. So in our way we're accessing this, we're having some class. We create a fraction, we'll create a new fraction, and we want to assign it a numerator and a denominator. So we need to go ahead and. You can see though, after we assign that, we cannot just directly print these fields. We have to do that through these accessors. So just keep that in mind. It's one of, I guess, a limitation of the Jack language. All right. So we're going to create a new constructor based upon what we said. We want to create a new fraction, give it a numerator and denominator. So in our constructor for a new fraction instance, we simply say let numerator equals x and let numerator equals y. Those are the x and y, the arguments we pass to the function. We can go ahead and reduce this fraction down so that we don't just end up with some non-reduced fraction, and we return this. All constructors must return with that statement, return this, and that returns the base address of this new object we are creating. We'll see that when we implement classes, this is really just a pointer to a base address of an object in. So we need to then figure out how we reduce our fractions. Let's go ahead and look at that. We know that if we want to pass 10 over 5, well, that's going to be just 2 over 1, whatever. So we need to figure out a way to reduce that. Let's go ahead and think about what we do. We can create a variable g. We're going to say the g is going to be the greatest common denominator. Okay, so we say let g equal to the greatest common denominator of the fraction, the numerator of the denominator, and then go ahead and use that to divide and reduce everything down, and finally just return. So in this case, we're actually modifying the class properties themselves. There's no need to return. Okay, well, to create the greatest common denominator, we probably need to have some algorithm to do that, and there's code that we can implement that. So in essence, we now have some methods that we can now use to work on the class. Methods will operate on instance of the class themselves, and then functions inside of a class. Those will actually then return values and just our general purpose kind of functions. It's slightly different. Mention this as a reference in the constructors, yes. And then I guess contrast to Python, it's worth pointing out that we must end functions with a return statement. In Python, you're just going to fall off the end of the world and you're okay, but we need to end things with. All right. So we have our fraction class. We started creating some various items for that. We need to have a way to add fractions together. All right, let's implement that. Remember before, we assigned a value to fraction A, a value to fraction B, and we said A dot plus, so we're calling a method of A, our first fraction, plus B, and we pass it another fraction. So you can see this in what we have for our function, our method. We have method fraction plus, so it's going to return a fraction, and we pass it a new fraction called other. And inside of this function, we're going to create our numerators. We're going to sum the numerator times our other fractions denominator. We're going to add that to the other fractions numerator times our denominator. And we simply then return the results of this. So we're returning a new fraction. All right. Next, we have now a way to assign a new fraction. We have a way to then reduce fractions. We have a way to add fractions together. This is working with one fraction object with another fraction object. And last is going to be the print abstraction that we made. So if you remember, we want to print 13 over 15. Well, to do that, we're going to call print the integer, the numerator. We're going to print the string with the slash, and then print the denominator. We're done. I guess it is worth mentioning, in our language, we do not have garbage collection, meaning we're not always looking for references to old objects and deleting things that aren't being used. So you must handle memory yourself. And typically we do that by having a dispose function where we just call the system memory class to deallocate our self and return. That's now kind of recycled stuff. All right, that's our fraction class. I think that's about everything. So we can see we have the implementation of the fraction class, and when we use it, we create new fractions. Call that A, fraction.new, 2 over 3. Let B be a fraction.new, 1 over 5. Excuse me. So we call the constructor. That generates this new fraction, returns a reference to itself, and then we can kind of use that. So in essence, kind of you peek under the hood what's going on. When we have an object that's really just some section of memory, we are going to then store that object's field variables. In this case, the variable A is a reference to a fraction that's somewhere off in the heap. And that's going to then just be storing the numerator 2 and the denominator 3. Likewise, B is just really a reference to some fraction that's storing 1 and then 5. So here's kind of what that might look like somewhere on RAM. Of course, we have all of our registers, we have the stack, and we have this heap. And that heap is where we're going to start using objects and store the references and data we need for our objects. We throw it on the heap. Objects now are really just pointers to this collection of associated field variables. And then part of the Jack system is providing some of these memory allocation services. So that's the abstraction that we have. We have A is just this object that has some fields, and then of course we implement that onto memory, and we'll worry about that later. We don't need to do anything yet. All right, stopping there. That's an example of going through how this object-oriented class structure kind of works. Next up, I'm going to talk about looking at a linked list. Yeah.